Okay, so there is another vector that we use in our calculations. So in space, we define a coordinate by 3 points. Okay, so just consider an arbitrary point in space, P. Okay, and certainly we have x, y, and z coordinates for this point. Now we can define the position of an object, the point where the object is, by means of a vector, because we generally use a reference point. This reference point may change, but in fact we can define the position of a vector, position of an object, by using a vector with respect to that point, which has the origin at O, by means of a vector R. Okay, as you see here. So the position of a vector can be defined as a vector at x, y, and z. In fact, this vector R has 3 components on each axis. So we have the xi component on x-axis, yj component on y-axis, and zk component on z-axis. Then we can write the position vector as R is equal to xi, yj, and zk. Okay, now this is the how we define a position vector. So it's not different than the force vector, but let's see what else we have. Now sometimes we need to define the relative position of an object. So the position of an object with respect to another one. Of course, again we use a Cartesian coordinate system. In this case, let's consider 2 objects. First is located at point A, and it has a coordinate of xa, ya, and za. Then the second one is located at point B in space, which has a coordinate of xb, yb, and zb. And now just imagine that I want to determine the relative position of object B with respect to A. So RAB. Now what I need to do is very simple. First, I define I write the position vector of object A. Then I have a vector R. Okay. And this vector R, summation of the vector RA and R, shall give me RB, the position vector of the object B. So we can write it by using mathematics like this. So RB is equal to R plus RA. Now as a result, I can write R, because the R is the relative position of object B with respect to object A. Okay, so R is a vector from A to B. R is equal to RB minus RA, and that is RAB. So R is a vector from A to B. RAB can be written as XB minus XA. These are the coordinates of object B and object A. These are the X coordinates, plus YB minus YA, J vector, plus ZB minus ZA, K vector. Now I find the relative position of object B with respect to object A, or point B with respect to point A, let's say. Now I can define a unit vector also from A to B. Now in this case, what I need to do is just divide the vector relative position vector to its magnitude. Then this will give me the unit vector. Now, of course, okay, this gives me then I can write the relative position from A to B as the magnitude of the relative position vector from A to B multiplied by the unit vector from A to B. Okay, so this is how I define the position vector of an object and relative position of a vector, position of an object.